esteemed panelists, and my dear fellow dreamers. I am Filza Thajudheen, and today I am privileged to present my research titled Development and Biodegradability Analysis of Chitosan Orange Peel Composite as a Sustainable Material. This research is not just a scientific inquiry, it is a call to action. It addresses one of the most critical environmental challenges we are currently facing, the ever-growing plastic pollution. This study was conducted under the mentorship of Dr. Thajudheen, and I present my immense gratitude to him. As we delve into this study, Plastic is undeniably one of the most widely used material in human history. But as you know, its usage comes with a grave cost. Every year, over 300 million tons of plastics are produced globally, with a significant portion of it ending up in oceans, ecosystems, and landfill. So, in the middle of this crisis, the need for a sustainable alternative is critical. So this is where I implemented Chitosan, a biodegradable biopolymer. It is renewable and a biopolymer, and it has excellent film forming properties. And we didn't stop here. We have orange peel. It's an agricultural waste that we often discard as a waste, and I've envisioned this orange peel powder. And orange peel is rich in cellulose and pectin. These are the components that enhance biodegradability. So by combining chitosan and orange peel powder, I envisioned a solution that can be sustainable material and can be an alternative to traditional plastics that we use nowadays. Objectives. My study mainly focused on two primary objectives. The first one is to develop a sustainable material that can be an alternative to the traditional plastics that we're using now. And the second one is to transform agricultural waste into valuable resources. Now, let me now walk you through my methodology. My methodology can be divided into three phases: preparation, integration, and testing. For the preparation and integration phases, as you can see, I've used chemicals and equipment. Chemicals were chitosan, acetic acid, distilled water, orange peel powder, OPP, and equipments were oven, ultrasonic sonicator, desiccator, magnetic stirrer, petri dish, and a grinder. Now, the preparation process. So the preparation began with chitosan, a natural biopolymer, a renewable biopolymer. The chitosan was dissolved in acetic acid to form a solution. Then orange peel powder was collected from the market. It was dried and grinded into fine powders. And this fine powder was later incorporated into the chitosan solution. And a sonication process was done. The sonication process was done to enhance the dispersion of orange peel powder in the chitosan matrix. And after these composite solutions were prepared, they were poured into molds, and they were dried, and it was collected as a polymer film. Now, entering into the last phase, the testing phase. I have made total 3 composites, the 0.1 weight percentage of orange peel powder and 0.2 weight percentage of orange peel powder, and they were compared to a neat chitosan sample, a blank sample, and these 3 samples were buried in soil for a period of 28 days, and the changes in weight, texture, and appearances were evaluated. Now, the most interesting part, results. As I said, I had 3 composites in total. So the second composite, the 0.2 weight percentage of OPP, it had the highest amount of orange peel in it. And the last one, the blank composite, it was just pure chitosan with no orange peel powder. And at the end, you can see the degradation process. The first one, 0.1 weight percentage OPP, had a degradation of 9.69%. And the 0.2 weight percentage of OPP had a degradation of 44.11%. And a blank solution, a blank sample, had a degradation percentage of 7.23%. So, the question remains, why? Why did this happen? Why did the 0.2 weight percentage of OPP had the highest degradation percentage over a span of 28 days? So, as we look into these results, we come to the conclusion that the cellulose and pectin content in the orange peel powder significantly enhanced its biodegradability. It provided essential nutrients for the soil microbes, and it accelerated the biodegradability process. Now, as I said, my key findings were the 0.1 weight percentage of OPP showed a moderate degradation, and the 0.2 weight percentage of OPP exhibited a highest degradation, and the blank sample exhibited a minimal degradation. So we can say that adding orange pea powder into the chitosan matrix significantly enhanced its degradation, and the impact of OPP was very high in these composites. In conclusion, I can say that the potential of combining the chitosan, a renewable biopolymer, and orange pea powder in agricultural waste, the degradation is very high, and I can say that it's an alternative to traditional plastics that we are using now. This study addresses one of the most facing challenges that we are facing now: plastic pollution and agricultural waste. And I developed a solution by combining these two materials, chitosan and orange peel powder. And that's it. Thank you. And now, before concluding, I would like to add my future plans. I had 3 future plans in my mind. The first one is to add varying concentrations of orange pea powder within the chitosan matrix. And we can, by adding varying concentrations of orange peel powder into the chitosan matrix, we can find a balanced degrading composite. And the second one is to do an environmental testing. We can test these 3 composites across several soil types, different climates, to get a global result. And the third one is by incorporating many other agricultural waste. As I said here, we used orange peel powder, and I can use many other agricultural wastes like pineapple peel, tapioca peels, and even cornstarch. And by adding these agricultural wastes, we can have a multifunctional degradable composite. And that's it. Thank you.